Let's solve another logarithmic function. Suppose I had to solve log of x plus log of x, 2x minus 4 equal log of 5x. So the idea here is going to be that if I can write a log on one side and log on the other side, then all of a sudden I can equate what's inside. So I'm going to use the log rule since we're adding these logs. Remember, there's a log rule that says log, the product rule, a times b is equal to log of a plus log of b. So I'm going to use this rule backwards and write this as a single log. So with that log, looks at log space down here. So I'm going to write x times 2x minus 4. And this is equal to log 5x. So because the bases are exactly the same, the only way these two log functions can be equal to each other is if what's inside of them are equal to each other. So then all I need to do is, well, let's figure out how to make these two inputs equal to each other. So I'll write that down. Right? Another way of doing this is to raise both sides to the 10th. Raise this, use this as an exponent of 10, exponent of 10, and then use the inverse concept. But this is, I think, simpler for logs. So now I'm going to distribute x here to both sides, and I have to solve this, but what kind of equation did I just create? And the answer is, this is going to be quadratic. So I'm going to choose a quadratic methods. I can use the quadratic formula. Where all of a sudden I'm trying to solve this particular, function. Okay, or I can factor. I'm going to try factoring first. So I'm going to subtract to factor. Again, no matter what I do, if I factor or use a quadratic formula, I have to get everything to one side and equal to 0. So subtract 5x from both sides. And I get the following. Combine like terms. And now recognize that, okay, I don't have to use this at all. This is a simpler thing to solve. It's a quadratic. So the whole idea is to factor and equate both factors equal to 0. But this one, since there's no constant, I can just factor out the x. There's a result of factoring out the x. Again, it seems like I'm doing this going backwards again, and I am. But first I needed to get this expression to the other side. I did that. This is the result. And now the only way I can have a product equal to 0 is if one of the factors is equal to 0, say this one. So one of the answers is potentially 0. We'll get the other factor to be equal to 0. So I'm going to solve this and add 9 to both sides. I can now notice linear, both two linear equations I generated, divide by 2. And this is potentially another answer here. Now, you're not done here because you need to check. So this is a 2 potential answers, but I need to check. I look at this equation, I immediately notice that, remember, the domain of a log, domain of just a simple log, say b x plus y, that is going to be 0 to infinity. So, and it doesn't include 0. So this cannot be 0. It has to be greater than 0. So this answer is no good. So I generated a 0. When I solve this, that's not an answer. What about this one? Well, it's 9/2. it serves this one good. This one seems to be hidden a bit to me, so I'm gonna just check it anyway. Like maybe could I generate a negative number here? I don't know, maybe I could. So I'm gonna just check x equals 9/2. So I'm gonna get log of 9/2 plus log of 2 times 9/2 minus 4, and this should be equal to log of 5 times 9/2. So do I have an equality here? Let's figure this out. It's going to cancel here. What I have now is log of, then again, I got 9 minus 4, that's a 5. And I can see that if I apply the log rule, I can, again, using this log rule backwards, I can multiply these insides and I'll get exactly what's on the left side. So it'd be 5 times 9/2, and so there I have equality. So this checks out. So the solution, there's only one solution here. The solution is x, and the answer is 9/2 is the only solution to this.